to FO Talks. I'm Peter Isackson, Fair Observer's Chief Strategy Officer. Today, I'm joined by Sanjay Mittal, a Silicon Valley entrepreneur with a track record of successful investments in the field of AI for more than 30 years. He's the founder and CEO of Predictika, a pioneer in conversational AI using generative AI. Sanjay, it's a pleasure to have this occasion to talk to you about a topic I've been very much involved in. I'm referring to the tsunami known as DeepSeek, which I think upset a lot of people's lives. Could you give us just your initial thoughts or any random ideas you have that have been sparked by the sudden emergence of DeepSeek?
I think the first reaction when I read about DeepSeek is that I think it reaffirms what we all kind of grew up believing, which is necessity is the mother of all invention. So I think what you see this this is small a team of engineers in China that have been cut out from the latest and greatest GPU chips from NVIDIA, and they scrambled and they showed tremendous amount of creativity and inventiveness in how to build world-class, LLM, which is really the underpinnings for AI today, and do that on a much smaller budget than OpenAI and the Googles and so on. But they didn't, it's not just that they use cheaper chips, but they actually came up with some interesting new ideas, different ways to train the system, different ways to refine the system, and ended up with a performance that is pretty comparable.
So do you think it's going to, do you think it will have, or has it already started to have an effect on the marketplace? As an entrepreneur, you must see the reaction of investors and developers and different people involved in the economy of AI. How do you see that today, and how do you see it playing out in the future?
So I think that, Meta had already kind of, set the ball rolling in that direction a while back by open sourcing their model. So they built a model called Llama 3, which is open sourced. By that I mean the model was available for everyone to use. You could examine its weights, you can examine its underpinnings and all of that. And in fact, DeepSeek used Llama 3 for its own building. So DeepSeek didn't start from scratch. They actually started with Llama 3. So basically, there are two competing strains going on in the AI market. There are the proprietary ones from OpenAI and Google and Anthropic and so on, where they charge you some fee for using their models, and then the open source ones pioneered by Llama 3, but there are now hundreds of them, and DeepSeek is just the latest, where they're open source, which means you can license it for free. And more importantly, you can build on top of that, right? So I think the difference between Llama 3 and DeepSeek is that DeepSeek actually has published, and so has Llama 3, in fairness to Meta, they published research papers describing in detail exactly what it took to build this. So I think what that is doing is letting people build on top of that, and instead of dealing with a closed box where you have no idea how it is being done, so you can't learn from it. The technology behind DeepSeek is now available to other people, and people are rapidly out there trying different things. And so I think it'll foster innovation at a pace that is even faster than what we thought.
Yes, I find that side of it really interesting, the fact that it's open source. I'm not sure, as a non-technical person, what that means to have an open source AI. Does it mean you can see everything that's there and you can transform it? Does it mean that we can understand how the intelligence itself works? What does open source mean in relation to, say, proprietary technologies?
Very good question, Peter, because open source actually has multiple implications here. So when we say open source, the software, which is where the term open source came from, the idea is that this entire source code is available. It's in the public domain in the sense that anyone can see it. It is not available for random purposes. There's a special license called copyleft that controls open source licensing. And what the licensing says is that you have access to the source code. You can modify it all you want, but any change you make has to be put back in the public domain. So you cannot take an open source piece of software, make changes, and hide that. That is against the licensing policy. But that aside, the entire source code is available. Now, when you talk about open sourcing these LLMs, that simply means that the entire model and all the weights behind all the parameters is available to a user, but by itself doesn't tell you what the techniques were that went into getting the model to that point. That is not available, right? DeepSeek has gone a little bit step further where they publish some of the techniques, but not everything. So, I mean, just a quick digression. The LLMs go through kind of two stages, right? First is they take all the content and then they build a deep model where to basically do what is called the predict the next word kind of a model. So the latest models are built on using pretty much all the published content on the internet, right? So, the latest models from OpenAI and Google, the Gemini 2 and the OpenAI's O1 and O3 models, they contain everything that's in the public internet, which means all the websites, all the books, all the articles, everything that is publicly available has already been used in this, and that probably is on the order of few terabytes of text. On top of that, then they do a lot of fine tuning and training. The real performance comes not just from the raw text. It comes from the fine tuning and the refinement that is being done. And companies like OpenAI have not been very forthcoming on what exactly are they doing there. They talked about that in the early versions, but in the last couple of years, they've kind of clamped down on talking about exactly what kind of refinements and fine tuning they're doing. DeepSeek, on the other hand, has at least published some of what they've done, from which people can learn and adapt that and modify that and so on. And I think we're seeing the impact of that because the Allen Institute in Seattle just came out with their own open source model called Tulu 3, which they claim to be better than DeepSeek. And we have not actually looked at that, but that just got announced last weekend after DeepSeek. So I think you're going to see more and more of these models coming out from different groups that are now building on top of each other's work.
So do you see, from your point of view, is that a good thing or is it something to worry about? The fact that so many new actors can come onto the scene and occupy center stage, as it were, the way DeepSeek has done. And
I think it's great. I think it's great. I mean, if you look at software, from the day the software business went open source, I think the space of innovation has been phenomenal. I mean, I look at my company; it's a tiny company. We are only a handful of people, and our entire software stack is built on open source. The operating system is open source. The Python language is open source. The libraries are open source. The drivers are open source. I mean, other than the code that we write, the entire stack that we are built on is open source, which doesn't simply mean it is open source. It means that as people find bugs, there are these faceless people out there who are maintaining it. So Python, we are now on Python version 3.12, 3.14, 3.15. There are people who are continuously looking at these bugs and fixing them. So we are relying on this army of people who are kind of selflessly out there maintaining, whether it's operating system or the programming language or the drivers or the libraries. LLMs come out and immediately there are Python libraries on how do you interface to the LLM or fine tune. So the software, the pace of innovation in software would be, I would say, many orders of magnitude less were it not for open source. I think the same thing is going to happen in AI. Once the LLM models get open sourced, I think the pace of innovation is going to be much faster. So at one level, that's all great news. I mean, I think as an entrepreneur, as a scientist, I think it's the best thing that can happen to the field. Now, business-wise, some will benefit, some will not, but that always happens.
So do you see the way you describe it is very interesting. It would appear to be a movement towards what I would call democracy, where everyone can be aware of what's being done and then can draw their own conclusions about why it's being done, which addresses some of the ethical problems people have identified with regard to AI. Is what you're talking about a spirit of democratic collaboration? And would you contrast that with, say, what's been said about or what's been reproached about OpenAI, that it's hiding everything and making it as opaque as possible and using it for profit motives that we're not even sure what they're based on?
So I don't want to turn this discussion into pro and con OpenAI, because I think that is not relevant. I think what's important is that with technology as important as LLMs and AI becoming so important, having them open source, open to inspection, open to building on top of that, modifying it, trying different things, I think is great for the field, because the technology becomes so complex that it is beyond the comprehension of any single person, even the smartest people out there. So the more people can get a look at it, try it out, take it apart, build it in different ways, the better we will be at understanding and shaping it.
So do you think there should be an obligation that AI that's used for any public purpose should be open source and have all the features of open source? That is, that it could be examined by anyone who's using it. Now, I asked that question, I'll let you answer it, but it also, I think, implies that there's a further question about when I say something that's going to have a public impact. If you take defense applications, obviously, I would think that anything that's being deployed for defense, people would say, well, no, that cannot be open source. Am I right? Am I reading the industry itself correctly?
Yeah, I think you asked a number of things. Let me see if I can answer them in my way. First is, who should decide whether all this should be open source or not? The government should definitely not be in that business. I personally think the government has no role in this. I think the market, I really believe, imperfect as the market is what should decide, in the sense that there's a cost benefit analysis, right? If OpenAI or some other company says, look, we have an LLM that can really do certain things much better, but you're going to charge money for it, you have a choice. If you think they really are doing something better, you should be willing to license it and pay them the fee. On the other hand, if there is an open source version that can do 80% of that, and that's good enough for you and that you get for free, then so you as a consumer, or you as a builder of application on top, should be the one deciding what the trade-offs are that you want to make. I don't think any government is smart enough to say, okay, AI is so important that should be open source, or AI should not be open source. I think that'll be the wrong way to do it. And you can see that, for example, in the way there was this the Defense Department has tried to build their own software for chip design and programming and so on, and almost all of them have basically floundered. They've gone nowhere. It's the open market development of technology that ultimately succeeded. And I can give examples, but that's not relevant here. So now, if you're building the next 7th generation fighter and it needs to have some AI software, and should they use open source or not, is something I think I'll let them decide. They obviously need to have much tighter control over it, a lot more testing. But is it better done through someone's proprietary version or OpenAI? I think it's a matter of evaluation, as opposed to philosophical decision about one way or the other.
That leads me to another question, which I think you probably know quite a lot about, and that is the role of chain of thought. When DeepSeek came out, there was a lot of talk about how it reveals its chain of thought. Is this, from a programming point of view, is this something that's always available? And is it something that's necessary to help us understand what we're getting out of AI? Because people are going to it to get some kind of productive advantage, don't they need to know how its chain of thought is working, and how transparent can that be?
I think that's a very good question, Peter. So chain of thought is a relatively new add-on to LLMs. I mean, relatively new meaning it's probably no more than a year old. So even less is understood about chain of thought than LLMs. I'm myself trying to figure out exactly what's going on and how good it is. Our initial experience, and we've done fair bit of testing with chain of thought, is that it does certain things very well and it does certain things poorly. And let me explain. If the chain of thought really is showing how it is arriving at a decision, and it can show that to you, that is value, because you understand. It's like you ask a student, solve this problem for me, and they solve it, and then you say, explain to me how you did it, and they can take you through step by step, and the step that they're taking you through are the steps they themselves followed. So then you have more confidence, right? So I don't know if you remember, when we used to do maths problems, some teachers would grade the maths problem strictly on the answer. Some would ask you to actually show the steps. And even if you got the answer wrong, if you were right up on the step, they'll give you marks for, okay, you're right up to this point, right? So that's where the chain of thought has value. Then there are other situations where, as human beings, we have a lot of very powerful pattern matching capabilities. So we solve the problem one way, and we explain how we solve it in a different way. So the two processes are actually somewhat independent of each other. And what we are seeing is that some of these LLMs, when they start to give you a trace of what they're doing, the trace seems to be divorced from how they actually solve the problem. And a chain of thought traces seem to be just as much subject to hallucination as their attempt to solve the problem. When that happens, then now you're dealing with two complex beasts that you're trying to figure out. You're trying to figure out why it got the answer wrong, and you're also trying to figure out why it gives the wrong explanation. So instead of dealing with one complexity, now you're two independent sources of complexity to deal with, and I think that makes it much harder to understand. So I think if the chain of thought really is the chain of thought of how to solve the problem, I think it'll be very valuable. If the chain of thought is something that is almost an artifact of what it actually, how it solved the problem, then I think it is far more damaging and useless.
Yes, that's a very interesting thing to think about, because my first impression was that if you introduce the chain of thought, if everything is explained as it's being presented, then it gives us a real possibility of understanding the thought processes, if there are thought processes, because that's the other question is, can AI think, or can it simply produce or reproduce a series of processes that are pretty opaque in the end, and they depend on whatever the input was that it's working from. So we're always in front of a mystery. I think that's what you're saying, right?
Well, I think, so let's say, who coined the term chain of thought? We human beings coined the term chain of thought, right? We know what thought means. We don't know whether LLMs think or not, right? I mean, that is still an open issue, because at least in a lot of the experiments we have done, I'm willing to say there is no thought going on at all. It's pattern matching. They look at the new problem, they match it against the massive corpus they've been trained on. They find similarities, and they do very, very sophisticated pattern matching, and then they try to answer the question based on that. That is not thought. Now, some of the very, very recent models, and I think the OpenAI's O3, which is their latest and greatest, it is barely being made available to the public. I've had a chance to play with them a little bit. They are beginning to show some hints of real thinking going on, right? But they are so new that till very recently, in fact, DeepSeek they were hidden behind this $200 per month license fee and only made available to few developers. The moment DeepSeek hit the market, they suddenly made some versions of O3 available to us peons, if you will, right? Because you're not the big spenders. So I'm finally getting a chance to play with O3, and this is even as we speak, we're trying it out. Early indications are that they actually have something more interesting along the lines of chain of thought. The DeepSeek, the Gemini 2s, the OpenAI O1s, none of them really did anything that we would remotely call thinking. O3 may be doing a little bit, but I think we need to play with it a lot more to see that.
So as it grows, as the developers experiment further and develop further and use technology that's always more sophisticated, more powerful, is it reasonable to think that it will help us to understand as users what we're using and how it's achieving the goals we set for it? And isn't that kind of transparency something that we should expect and require from future versions of AI?
So let me give a quick digression here, because when I was doing when I've been a computer scientist for a very long time, and I used to read up a lot. There was a very interesting paper. There was a well-known professor in computer science who was the chairman at Yale Computer Science, Alan Perlis. Most people probably don't know his name, but if you Google him, you'll find out. He was a very, very highly respected professor in computer science. So he and one of his colleagues, I think Richard Lipton, they wrote a paper on mathematical proofs as a social process. And the key thesis was that if you look at the complex mathematical problems for which people have tried to prove, trying to look at the proof step by step almost never gains acceptance, because the proof itself is so complex that no one can really understand logically, using sort of like Bertrand Russell style, logical deductive reasoning, that, you say, this lemma, then you make an inference from that and make another inference, and it goes on. And then you say, okay, at the end, I'm convinced that the theorem has been proved. It never happens that way because they get so complex. The way they get accepted is through a process of social usage. You take the theorem and then you apply the theorem elsewhere. And the more and more people apply, and they find that when they apply it, they don't lead to inconsistencies over a period of time, they say, okay, I believe it. I mean, look at Einstein's theory of relativity. No one has ever proven it. No one can say that it's a law. It's that, even after 100 years, we still call it theory of relativity. But every time someone tries something, whether it is the gravitational waves or whether it's black holes or anything, it turns out that yes, his theory predicted that. So the confidence in his theory keeps going up more and more, but it has still not been converted into a law, right?
No.
So the reason I'm saying all of that is that I think LLM giving an explanation for a complex phenomena will run into the same problem. The explanation they give will themselves be so complex that, I mean, and we're already seeing that. I mean, some of the work we have done, we took a very, very simple puzzle, the river crossing puzzle. Someone has to move 3 or 4 things across the river, and there are some simple rules you have to follow. When the newest LLMs go into the chain of thought, their explanations are so long, so complicated, that if you're not following it very, very, very seriously, you'll easily miss out the mistakes. And there are mistakes buried in there, and you'll miss them out. So to think that you can use these LLMs to resolve complex social issues by coming up with an explanation that we'll all suddenly buy, I think is a mistaken hope.
I would totally agree with you. What I see as the advantage of using AI even today is not that it's going to solve our problems, but it allows us to refine our own thoughts as we create a dialogue with AI, because it is capable of dialogue. It is a voice. I consider it to be like a human voice. It's not a real human voice, but it's one that helps us refine our own thinking. And if we take the question of solving social problems, social issues, it seems to me evident that AI can only give us information or ideas, or, I mean, repeat other people's ideas, really, rather than giving ideas, not rather than thinking on its own. But it can construct and and recognize patterns that help us to think about the patterns we use in our own minds, which means that the responsibility has to end up with human beings. And we have to find ways of using AI in such a way that human beings are always in control, and thinking human beings, not executing human beings. I make a distinction because if I take, I'm very much involved in thinking about how politics works and how our societies function. And the people who pass laws, make laws, pass laws, execute laws, are people who are not necessarily thinking. They're applying principles and ideas, but they're not necessarily thinking. The people who think are the people who are subject to those laws. So I see a basic problem of democracy being making people who are involved in any kind of action, whether it's economic, cultural, social, making them aware of what goes into the decisions that they have to make, either individually or collectively.
So, do you have a question in there? Because I mean, as you're talking, my mind was going in different directions, and I think it might take us very far from AI. So maybe let's bring it back.
Let me come back to something very concrete. There's another question which I think I would like to understand further, and that is both in terms of what it is in itself and what it means in terms of how the AI economy is going to evolve. That's distillation. We've heard a lot about the fact that what DeepSeek has done and one of the innovations it's highlighted is that it's used distillation to reduce the amount of energy, the amount of data, the amount of anything that goes into what you're trying to produce, and make it more efficient and make it more available to and more consumable by the people who need to consume. So what is distillation? How important is it? Is it something new? And is it something that has a future?
So I'm probably betraying the limits of my understanding of DeepSeek. So I'll say that up front. My understanding of distillation, I'll talk about, and I may be off. My understanding of distillation is basically what people have always called, supervised fine-tuning, reinforcement learning, human feedback. There's a bunch of technologies that have been around that lead to distillation. So typically what happens with LLMs is once you build the basic LLM, what is called the foundation model, then you put it through some kind of a fine-tuning or refinement, and that leads to a new model we built on top. That is the result of that distillation, right? So it's like you take the model and say, okay, now let's see, take a bunch of mathematics problems, right? And kind of fine tune it for those problems so that when those problems are thrown at it, it doesn't have to search through its trillion parameters that deal with Shakespeare and travel and so on, but it can narrow it down to only the thing that really dealing with solving multiplication and calculus and set theory and all that kind of stuff, right? So the way you do that is that you basically give it a whole bunch of problems in that subject matter, and you know what the answer is. So when it tries to solve, it figures out what parameters are involved and how do you make those inferences very quickly, and you build a kind of a distilled model on top of that. So that has been around. I mean, that has been the crux of how OpenAI really got the LLMs to perform. I mean, if you look at the history, the LLMs were invented by Google, and they also invented the transformer, which is the technology that takes the foundation model and returns the answers. But OpenAI took that the next step with doing this distillation or fine tuning, and gave performance. So the DeepSeek guys basically took that to its logical conclusion, which is instead of just doing it across everything, do it for different subject matters. So now you have lots and lots of these distilled models. And so each model itself is relatively small, but it has been fine-tuned or trained for class of problems, programming, logical, maybe legal issues, and et cetera, et cetera, et cetera. So you have 10, 20, 50, I don't know how many, but they have a large number of these models sitting, each of them very small, very efficient, right? So that is always being done, but I think they probably took it to the next level, which is let's do it systematically. I think what OpenAI was doing, and again, this is opaque, but my understanding is they would have an army of people and they would give them test cases and say, okay, the LLM got this wrong. Now, if I show you, if you get this prompt of the answer that come up, which one would you prefer? So people would say, choice A, B, C, I prefer B. So they see what weights would lead to B, and they would create in the distilled model, they would pick out those parameters and change the weight so that when the question was asked again, they would consult the distilled model before they would consult the main model, and things will go faster. I think what DeepSeek did is, instead of doing that haphazardly over everything, they did that in a segmented manner, maths problems, programming problems, et cetera, et cetera. So they had kind of vertically focused distilled models built, which probably led to smaller size and better performance. I think we should expect to see that happening more and more.
So could it be like Moore's law, that every 18 months we will distill even further and intelligence will be reduced to the smallest, to a tiny particle in the end?
I think it shows the developers that, let's say tomorrow you're building a tax expert AI. Right? You don't need to actually train it on everything because the LLM underneath actually has everything. You basically take your 1,000, 10,000, 100,000 text cases on tax law and fine tune it, and the distilled model knows a lot about tax extracted from everything else. So it'll do a faster job. If you tomorrow you ask it about weather or tell me about Marriage of Figaro, it still knows how to do that, but for that it'll drop down to its underlying model, take its time. But if you say what is the best way to give tax break in Switzerland, it has that information already collected there. So in terms of building specialized models for bounded problems, I think this might be the way to go.
Okay, so is that what you're describing? Sounds to me a little bit like the things I've heard about what an AI agent would be doing. That is, you can train your AI to do something that corresponds to your own concerns and your own needs. Are we talking about the same thing?
No, I think I'm talking about fine-tuning the model or training the model to extract something relevant for a vertical. What the agent would do is, agent would be kind of given its task and it's running autonomously. So it can go touch different, go to the web, go to other data sources and put the answer together. So it's kind of running on top of these fine-tuned or distilled models.
Okay, so both could work together and we get greater efficiency.
Absolutely. So for example, think of it, let's say you have an AI agent that is a travel planner, right? And so you go and say, hey, plan me a 1-week trip to Switzerland and I want to cover these things and I want to go in winter, right? Now, it can either go to a general purpose LLM, which could be slow and expensive, or someone could have created a distilled model for travel, which extracted information about all the places in the world and things to see and restaurants and so on. So it's still a big model, but not trillions of parameters, maybe few low billions. And that could be running on a much smaller server, probably fit on your phone or your laptop tomorrow. And so your travel planning agent can do this much faster and cheaper, right? So
yeah, that's fascinating. I mean, it can give people a good idea of what we can expect in terms of the services and the conveniences that AI will offer us in the future.
I'll give a very concrete example, because I've been actually looking at travel plans since I travel a lot. I've been trying to test the limits of what the LLMs can and cannot do. So, we had gone to, Lake Garda last year. So I gave it a simple problem. I want to travel from Riva del Garda, which is at the northern end of the Lake Garda, and I want to go to Limon sul Garda, which is on the west side, and then I want to go to Melsesin, which is on the right side. So plan the itinerary. So what it did is it said, okay, start at Riva del Garda, you go to the right, and then you just drive across the lake, because it has no notion that to drive across the lake you actually need some way to drive. So I said, well, there is no bridge there. He said, oh, take a ferry, but the ferry doesn't take doesn't take a car, right?
Yeah.
So that is the kind of thing that an AI agent could do, which is it takes the underlying model, the model produces the itinerary which has bugs in it, and then it's okay. Can I go from point A to point B? No. Then it goes back and says, look, I can't do this. Then it can plan an alternative route for you. And the right route is you go back to Riva del Garda and then come down to the other side. That's the only way you can do it. Right.
Yeah.
So the underlying model is going to be used to produce some possibly imperfect solution, and then AI agent sitting on top can do that refinement to check, either are the trains available? Is there a bridge? Is there a ferry? If the ferry takes car, if not, then you go something different, right?
Okay, so in the end, what is AI getting smarter, or is it just getting more efficient? And I mean, there's the eternal question: when can we expect super intelligence, or when can we expect the singularity? Is it reasonable even to ask such questions?
So let me start with the easy one, right? Is the AI getting smarter? Yes, I do believe that. I think that the LLMs are definitely getting smarter. I mean, you just need to see the progress from 2022 when OpenAI came out with ChatGPT 3.5 or something, to now O1 and O3 models and DeepSeek and everything else in between. These programs are getting much better. I mean, they do a much better job. They hallucinate less. They make less mistakes. They're not perfect by any means. They still make mistakes, and you have to be very vigilant. But overall, they're doing a much better job. I mean, in my mind, there is no question about that. Will they get to AGI, artificial general intelligence, or would they be as smart as the smartest person? I think that's an open question. I mean, there are people, for whatever reason, believe that it's right around the corner, 2025, 26, 27, this decade. Others think it'll never happen, and everything in between. So,
Well, my personal feeling is that if the day somebody says it has happened, we'll discover that it isn't. We now know that human intelligence is different from whatever it turns out to be. I think we have the difficult problem today is to understand what anyone means by AGI or super intelligence, and how can you compare two different forms of production of discourse, because that's basically what we're talking about in terms of our impression. How can you compare what a machine does with what a human does? I think in the end, this is my personal opinion, that we'll discover that we cannot compare them, that we can see how they produce different things and with levels of efficiency, accuracy, and speed that are easily contrasted and compared. But my personal belief, but it has nothing to do with intelligence itself. It has to do with the way we interact as human beings with the world. My personal belief is that we will discover that it's a wonderful sort of thing that does things very similar to what human beings can do, but it can never be the same thing. They're two totally separate entities. I don't expect you to agree with that, or anyone else for that matter, but I like to articulate what my own level of skepticism about what it is. At the same time, I'm just fascinated by everything we can expect it to accomplish and where it can lead in terms of either producing a better world, and there is the real risk that it's going to produce a much worse world than what we have today.
I think in terms of AI being useful, I think it's already proven. I don't think we need to debate that. Forget AGI, but is AI useful? Look at the Nobel Prizes last year, right? There were 3 Nobel Prizes given, 2 shared and one separate. They're all about AI, right? I mean, Jeff Hinton and what's the other guy who got the Nobel Prize in physics for the work in neural networks and so on. And then Dean Hassabis from Google DeepMind got Nobel Prize for AlphaFold. And I think another chemistry professor got Nobel Prize for discovering some novel proteins using AI, right? So if you look at those 3 different, I mean, the 2 were in chemistry, were independent works, but still using AI. So the role of AI in advancing science and doing something useful for mankind is already proven. I mean, it has got the stamp of approval of the Nobel Prize, right? But from there to whether we'll have AI that is smarter than all humans, I think is a much, much bigger issue, which has also scary implications. But here's a simple test, and I was just thinking about it as we're talking. Would an AGI program be smart enough to come up with an example that it could not solve? Right? We human beings have always created these conundrums which are impervious to our intelligence. I mean, simple example: a set of all sets is mathematical impossibility, right? We created that, right?
Yeah.
But would an AGI be able to come up with things of that kind, which says, "Look, I'm also stumped. I cannot solve this problem."
Yeah.
That would be the hallmark of super intelligence, right?
Could they create this similar drawings to Escher's?
Escher's, right? Absolutely.
So that's a very well. My thesis, I would say my intuition that tells me it can never be the same thing. It can be more powerful, it can be faster, it can be more accurate as far as facts are concerned. Because after all, humans, we complain that AI hallucinates, but humans hallucinate as well. So we've learned to live with ourselves as hallucinating beings, and we've learned to deal with the effect of hallucinations. And when I say hallucinations, we're surrounded by them. And one example is propaganda. And everything we get from the media. You don't know what's accurate, what isn't, what's believable, what isn't. But my central thesis, which is the challenge, my version of a Turing test, is can any kind of machine we can create possess what every human being possesses, and that's proprioception. That's the ability to perceive who we are in our environment, in space, in the physical environment we live in. And however many sensors you put on a robot, I don't believe it can reproduce. There's any way we could reproduce what is just there in an organic body, and that is proprioception. Whether it's humans or cats or mice, whatever, or insects, they all have proprioception. I don't know if that's ever been debated in the realm of AI theory.
I think it has been. I mean, I remember even when I was doing AI research a long time back, that was always considered, a key differentiation between human beings and an AI-powered machine, which is we live in the real world, we have agency, we perceive, we have our own motivations, our goals, and we observe the world, we perceive, we take actions, and all of that. And AI is a program, it has no connection to the physical world. Whatever actuators and sensors you give it are still very artificial. So until you get to the point where not only does it have all of that, but it also has some notion of independent goals and so on, we can't really call it intelligent like human being. right?
Exactly.
But that doesn't mean that in terms of a pure thinking machine, it could not exceed human intelligence. I think it's still it could probably know more than any of us. It already does. I mean, the LLMs today contain more and knows more about more things. And Google search already did that. I mean, Google search already
That's a
knew.
restricted definition of intelligence. The way the whole industry and the whole culture of AI is evolving, it's always going to be different, and and it's always going to remain mysterious.
Well, Peter, I really enjoyed this. You asked very good questions, and I think it made me think beyond what I think on a day-to-day basis. So I enjoyed this a lot. Would love to do it again.
And that's wonderful, and I absolutely insist that we will do it again. So thank you very much, Sanjay. It's been an immense pleasure, and we'll look forward to the next time we can pick up the conversation.
Thank you, and enjoy the rest of your day.
Join the conversation at Fair Observer and subscribe to our YouTube channel.